Having learned about various supervised learning algorithms, let us now jump to some of the unsupervised machine learning algorithms. Let us start with K-means clustering. A small revision on unsupervised learning. Unsupervised learning algorithms make inferences from data sets using only input vectors without referring to known or labeled outcomes. K-means clustering is one of the simplest and popular unsupervised machine learning algorithms. Well, the idea behind K-means is simple. We group similar data points together and discover underlying patterns. To perform the algorithms, we find a fixed number of K of clusters in a dataset. Now, the terminology cluster here refers to the collection of data points grouped together because of certain similarities. Clustering helps us understand our data in a unique way, that is, by grouping things together into a cluster. In clustering, we do not have a target to predict, but we look at the data points and then try to club similar observations and thus form different groups. Hence, it is a unsupervised learning problem. The value of K will define the number of centroids you will need in the dataset. A centroid is the imaginary or real location representing the center of the cluster. Now, every data point is allocated to each of the clusters by reducing the in-cluster sum of the squares. Now, for example, let us take this diagram and see. Just by looking at this diagram, we can say that we can see two clusters, one on the left at this side and one on the right on this side. Else, a person can even say that they can see four clusters. First is this, then comes the down part, then comes the next part, and then comes the fourth part. So it is based on the visualization that we are able to see the number of clusters, right? Thus, the means in the K means refers to averaging of the data, that is finding the centroid. To sum up, the K-means algorithm identifies K number of centroids and then allocates each data point to the nearest cluster while keeping the centroids as small as possible. K-means perform iterative calculations to optimize the position of the centroid. The value of K is a hyperparameter and can be decided by hit and trial and by observing the data, as we just did see over here. Let me just annotate so as to help you visualize. So one of the cluster we can see is over here, the other can be seen over here, the next can be seen over here, and thereafter it can be seen over here. Else, these are the four clusters that I am able to see. You might even say that you are able to see two clusters, one which includes these, the other which includes this. Other set of people can say that they are able to see 8 clusters. First is this cluster, thereafter this, and then comes this, the fourth one, the fifth one, sixth, seventh, and eighth one. So this is how we can say that the value of K is a hyperparameter can be decided by hit and trial or by observation that we have just done over here, right? So we'll just clear all of these drawings and move back. So the stopping condition is when either a number of iterations have been exhausted or when there is no change in the values of the clusters or the newly formed centroids don't change. Now let us look at the example and try to understand the procedure. We are first of all importing all the necessary libraries that we have. Thereafter, we have taken a personalized data that we have. So this is the data that we have, and the data shape is this. So let us just see all the rows that we have. So this is the data that we have. Thereafter, we'll be scattering the data just so as to see the different kind of clusters that can be done. Here in this place, if you don't want this line to be shown up, you can just add a semicolon over here, and there you go. Now let us try and visualize over here too. One of the cluster that a person can see is maybe this one, and thereafter maybe this one. Else a person will be able to see first this cluster, thereafter this cluster, and thereafter this cluster. So let us compute and see that what actually are we getting as the output, right? So initially I've taken the centers as 2, 10, 5, 8, and 1, 2 that we have. 1, 2, 5, 8, and 2, 10. These are the random centers that I have taken. Thereafter, we'll be doing the calculation. So let us directly move on to this step first. So what we do is that A, B, C are the random clusters that we have. Thereafter, this is the data that we have. So we'll be calling the k-mean calculation first. So let us move on to k-mean calculation. What does k-mean calculation do is it takes the list of the centers and the points that will follow them. We'll find the distance of the center values to each of the data points, and we'll find the Euclidean distance, and thereafter we'll find the minimum distance. Now, if minimum distance is equal to distance 1, then we'll append in first cluster. If not, and if it is equal to second distance, then we'll append in third cluster. Else, we'll append in the in the second cluster, else we'll append in the third cluster. And thereafter, we'll return the values of the new cluster points that we have, and that is something we are printing over here. So there you go. These are the points that we have and the new clusters that we have, right? But this is, we are yet not at our stopping point. We still have to, as we had discussed, it is an iterative process, and we have to again do the whole procedure so as to see that if we come up to a stopping condition or the number of iterations are exhausted. So what was the next step that we had discussed? It said that we have to take the mean of the center points. That is what K means, mean, right? So it is a bit confusing, tongue twister kind of thing, but I hope you're getting the point. So for that value, what we'll be doing, we have to save the values of the clusters into some variable so that it can be used in the next iteration. So we'll be using previous C1 for the same. Thereafter, first of all, what we'll be doing is that we'll be calling for new centroids, right? For this new centroids, what are we doing here is that we are taking all the values in the centroids, and thereafter we are taking the mean values, and that is something that we are again appending into the new cluster. So we have taken this list. This is the new center that we are taking. We are appending all the x values here, all the y values here, and thereafter we are taking the mean and we are appending it into A. The same value for B and the same for C. So that is something that we have done. We have taken number of iterations as 4 over here. We are calling for the new centers. After calling for the new centers, we are again doing the k-mean calculation as discussed over here. And thereafter, we are storing the values and the same iterative process. So let's just run it. So in our case, we got over here that for the first cluster, we just have 2 and 10, and it's just 2 and 10. Thus, the mean value will come as 2 and 10. Let's just check that. Yes, we are getting that. In this case, we'll be having 8 plus 5 plus 7 plus 6 plus 4, right? And that will range up to 30, and 30 divided by 5 will be equal to 6. The same for the 4 plus 8 plus 5 plus 4 plus 9, and thus we are getting as 6, 6. So this is how we are getting the new centers, and after the new centers, we are calling k-mean calculation, and these are the new clusters that we are getting. So this is for the second iteration. Now for the third iteration, we'll do the same thing. Now for the third iteration, as you can see, we are able to find the new centers, and after seeing the new centers, we are able to find the new clusters. So for example, over here, 2 plus 4 is 6, 6 divided by 2 is 3, therefore our new center is 3, and thereafter 19 divided by 2 is 9.5, and this is the new center. And thereafter we are finding the minimum distance of all the points to these centers, and we are arranging into the cluster. So to what we have seen for now, the clusters are different. We have not been exhausted in the number of iterations. As centroids are different, so we are not yet at the stopping point. But thereafter, if we see in a fourth iteration, although our centers are different, but our clusters are being same, and the same for our fifth iteration. So this is what our stopping point is. We are realizing, although the number of iterations and have not exhausted and the centers are being different, but the clusters are being same, and that is why we do not want to waste any of our resources to further calculate the clusters, and that is why we had a stopping point. To just add the stopping point, we'll uncomment this, and now we'll run again, and thereafter, after the second thing, it stops, right? Now this was something that I had coded externally so as to make you understand how k-means work from the scratch. Now let us see how does sklearn do it. So we'll be taking the uh, data of mall customers. You can find all these data and the notebooks on the GitHub link that has been shared with you. We'll be seeing the data shape. So we have 200 rows and 5 columns. So columns is customer ID, gender, age, annual income, and spending score. So this is an example of customer segmentation. Now I will want to segment my customers on the basis of their spending score, on the basis of their age, on the basis of the gender, on the basis of annual income, or even merging that if I compare gender and spending score, then how are my customers segmented? This is how the thinking process of k-means work, right? So what we'll be doing is that we'll be segmenting our customers based on annual income and spending score. So we'll be calling k-means. We'll be keeping a number of clusters as 5. So our labels will range from 0 to 4. So let us now see the centroids that we are getting. These are the centroids that we are getting after doing all the iterations till the stopping point. And this is unique label. Now I will want you to pause the video over here and think for yourself what will be the value of unique labels. So let us just print the values, and I hope that till now you have already deciphered that what will be the values of unique labels. So yes, it is 0, 1, 2, 3, 4 as we have seen over here, right? Now based on the unique labels, we'll be segmenting our customers. So this is the plot that I am getting after doing the whole customer segmentation. So let us learn how to infer from the visualization that we are getting. Now all the black points that you are seeing over here are the centroids. The y-axis is the spending score. The x-axis is the annual income. The purple zone says that the customer has less annual income and less spending score. The red zone says that the customer has high annual income but less spending score. The orange one says that it is average in between of annual income and spending score. Blue one says that the customer has less annual income but high spending score. And the green one says that they have high annual income and high spending score. So if a person has to run their own mall, and if they want to understand if they have to keep this product or during these festive season, what kind of customers are the target customers, they can use this data for the same, right? So let us just see at the point at the documentation of k-means. So our different parameters are number of clusters, maximum iterations that one has to do. So default is 300 and it has a stopping point, right? Excuse me. And number of workers, random state, number of jobs, algorithms, are attributes are cluster centers, centroids, unique labels. So cluster centers label, that is something that we have used over here. And it uses mini batch k-means. And this is the different example that they have taken. So now let us jump back to the different applications that k-means clustering have. So first is customer segment that we just saw in the computation that we did. Second is document clustering. So let us say that you have multiple documents and you want to cluster similar documents together. So clustering helps you for that. Thereafter, if you have, in the case of image segmentation, so if you have different pixels and you want to cluster similar kind of pixels, as you are able to see over here, red are the similar ones, green, and thereafter blue. Next is a very interesting application, which is recommendation engines. So let's say you want to recommend a song to your friend and you look at the songs liked by that person and then use clustering to find similar songs and finally recommend them to you. So this is a very common thing that you must have seen in your Spotify. This is how a recommendation engine works. So that is all for today. Have a great day ahead.